Okay, so for simplifying radicals, the first one is the square root of 50. Well, all you need to do is think about what perfect square goes into 50 and then simplify from there. So the perfect square that goes into 50 is 25, so I'm going to write this as the square root of 25 times 2. And then the square root of 25 times the square root of 2 is the same thing as this, and the square root of 25 is 5 times the square root of 2. And that would be my final answer. If you know this, then you can go straight from here to there, and that's fine, but this is just showing your work. So the perfect square that goes into 300 would be 100. So I would say the square root of 100 times 3, or the square root of 100, which is 10, square root of 3 doesn't have a perfect answer, so or it's not a perfect square, so there we go. Now this is a little bit different. When you're raising a variable, or when you're saying the square root of a variable to a power, then you have to think about it like this: a to the 6 to the 1/2 power. Because just remember, the square root of x is x to the 1/2. The cubed root of x is x to the 1/3. Fourth root of x is x to the 1/4, and so on and so forth. So this right here, if I'm saying x squared cubed, then that is x squared times x squared times x squared, because it's being cubed, which is x to the 6th, which is the same thing as saying 2 times 3, versus x squared times x cubed, which is x to the 5th. That's when we add. So this is when you multiply, this is when you add. Right here, this is a multiplication situation. So 6 times 1/2 is the same thing as saying 6 times 1, which is 6 divided by 2, which is 3. Or 6 divided by 2, which is 3. 3 times 1 is 3. So a cubed. Okay, so basically just ask yourself, how many times does the root go into that? Now it's a little bit different here because the root 2 goes into 7 3 times with 1 remaining. So you could think of it like this: the square root of a to the 6th times a to the 1st, which is the same thing as saying a to the 6th to the 1/2, which is a cubed, times the square root of a. And I'm going to go ahead and leave it as that because 1 or 2 does not go into 1. Okay? So another way, just like I said, how many times does 2 go into 7? 3 times with 1 remaining. So then this right here, 18, well, that is 9 times 2. So I'm going to say 9 times 2 times a times b to the 8th. That I can take the square root of 3. This I cannot, so I leave it inside. This I cannot because it's a power of 1. It doesn't go, 2 doesn't go into 1, so I say a to the 1st. B to the 8th, well, 2 does go into 8 4 times, so I say b to the 4th, and there is my answer. Okay, this one, that I cannot take the square root of. That I can. The square root of x squared is x, because x to the 2nd to the 1/2 is x. Okay, so that goes on the outside. Y to the 1st, 2 doesn't go into that, so I'll leave y on the inside. Z to the 9th. I'm going to rewrite z to the 9th as z to the 8th times z. 2 goes into 8, so the root goes into 8 4 times, so I've got z to the 4th on the outside with 1 remaining on the inside. And there's my final answer. Okay. Cubed root of 125. Well, in that case, just look at your power chart and say 125 is what cubed? And it's 5. So that's just 5. Cubed root of 40. Well, if I look along the 3's, there's nothing cubed that gives me 40. However, 2 cubed gives me 8, and I know 8 is a multiple, or is a factor of 40. So I'm going to say the cubed root of 8 times 5, which is the cubed root of 8 times the cubed root of 5. And that, since 2 cubed is 8, the cubed root of both is 2. So the cubed root of 8 is 2 times the cubed root of 5. Okay, and then this one. Well, 3 does go into 3 how many times? Once. So that's just a to the 1st. 3 goes into 12 4 times. So there we go. Because you could think of it as a to the 3rd to the 1/3 times b to the 12th to the 1/3. 3 divided by 3 cancels out, a to the 1st. 12 divided by 3 is 4, so b to the 4 times 1, which is 4. And that's where we got that. Which you don't have to write down the a to the 1st, you can just write down a. Okay? Let's do this one. Cubed root of 125 is 5. A to the fourth, however, I'm going to rewrite as a to the third times a to the first. This is the same thing as that, but this I can take the cubed root of. The cubed root of a cubed is just a. I can't take the cubed root of just a to the first, so there we go. Oh, cubed root. And there we go. Okay. If I have the cubed root of 16, a to the 10th, b to the 15th, well then, 16 is not a perfect cube. However, 8 is, so I could say that's 8 times 2. I'm going to say a to the 10th is a to the 9th times a to the 1st because 9 is a multiple of 3. And then b to the 15th. So, and I'm going to leave 15 because 15 is a multiple of 3. So I've got the cubed root of all this. Well, the cubed root of 8 is 2. Cubed root of 2, there isn't one, so I just leave it. Cubed root of a to the 9 is a to the 3rd, because 3 goes into 9 3 times. And then this I leave on the inside. The cubed root of b to the 15th is b to the 15 divided by 3, or b to the 5th. And there we go. Give me a second. Give me a second. Look at that. Okay, so the fourth root of 625. So fourth root means I need to go the powers of 4. Powers of 4, powers of 4, powers of 4, powers of 4. 5 to the 4th is 625, so that is just 5. On this one, the fourth root of a cubed b to the 12th. Well, that's the same thing as saying, can I take 4 out of 3? And I can't. So, a to the 3rd has to stay on the inside of the fourth root. However, b to the 12th, that's the same thing as saying b to the 12th to the 1/4. 12 divided by 4 is 3, so b cubed goes on the outside, and there's my answer. Fifth root, well, I'm going powers of 5. Powers of the 2 to the 5th is 32. So since 2 to the 5th is 32, the fifth root of 32 is 2. And then a to the 15th, well, a to the 15th to the 1/5 power is a cubed. And there we go. Okay, so let's do this one. The fifth root is 729, a to the 33rd, b to the 35th. 729 is not something that you like, if I raise to the power of 5, that's not one of my answers. However, I noticed that 3 to the 5th is 243. And if I look at that, 243 looks like it might be a factor of 729, so I'd check it out. 243, I'm thinking times 3, because 3 times 3 is 9. 12, and 3 times 6 and 7, so there we go. So this is the same thing as saying 243 times 3 times, well, I'm going to look for multiples of 5. So the largest multiple of 5 that goes into 33 is 30. So I'm going to say a to the 30th times what's left over, 3. 35 is a multiple of 5, so I'm going to go ahead and say 35. Now if I take the fifth root of 243 is, like we said, 3. Okay. That's not, so we leave that on the inside. A to the 30th, well, 30 divided by 5 is 6, so a to the 6th, taking care of all those, and then this does not, so I leave it inside. This is b to the 7th, because 35 divided by 5 is 7, and there we go. Just as a little reminder, the square root of 2 times the square root of 5 is the square root of 10, because you can multiply inside. Just like saying the square root of 4 times the square root of 9 is the square root of 36, and I can check that because the square root of 4 is 2, the square root of 9 is 3, and the square root of 36 is 6, and 2 times 3 is 6. However, I cannot say the square root of 4 plus the square root of 9 is the square root of 13. That doesn't work that way, because this is 2, and this is 3, and the square root of 13 is not 5. The square root of 25 is. So, when I multiply this right here, square root of 5 times 2 minus the square root of 10, I have to distribute this and distribute there. So 2 times the square root of 5 is 2 square roots of 5, minus square root of 5 times square root of 10 is square root of 5 times 10, or square root of 50, which further simplifies. 50 is 25 times 2, so I've got 2 square roots of 5 minus 5 square roots of 2. Square root of 25 is 5. Leave the 2 on the inside. So let's do this one. Square root of 2 times 3 square roots of 2 is 3 square roots of 2 times the square root of 2. minus the square root of 10 times the square root of 2. Well, this right here is the square root of 4, which is 2, so I've got 3 times 2, which is 6. The square root of 2 times the square root of 10 is square root of 20, and 20 is 4 times 5, so I've got 6 minus the square root of 4 is 2, square root of 5 it's not a whole number, so I leave it like that. And there's my final answer. Okay, so let's do this one. Distribute square root of 6. Square root of 6 times square root of 2 is square root of 12. Square root of 6 times square root of 10 is square root of 60. 4 goes into 12 3 times, so 2 root 3. 4 goes into 60 15 times, so 2 root 15. And I can't add these because they have different square roots, and so I'm done. Distribute, distribute. Negative 3 square roots of 5 times 2 is a negative 6 square roots of 5. Negative times a negative is positive. 3 square root of 5 times square root of 3 is square root of 15. It doesn't have a perfect square in it, doesn't have a perfect square in it, so I'm done. This one. 2 square roots of 10 times 3 square roots of 2a. Okay, 2 times 3 is 6. Square root of 10 times square root of 2a is the square root of 20a. Now this, 2 times 1, negative 1 is negative 1, or negative 2. Square root of 10 times square root of 10 is square root of 100, and then b is on the outside, so b. That's 10, so this might as well be negative 20b. This is 4 times 5 times a, which I can take the square root of. It's 2 times the square root of 5a. Well, 2 times 6 is 12 square roots of 5a minus 20b. And so let's do this one. Negative 4 times 1 is negative 4. Square root of x times square root of 2x is the square root of 2x squared. Negative 4 times 1 is negative 4. Square root of x times square root of 10y is square root of 10xy. Nothing in there simplifies. 10 doesn't have a perfect square, and x and y have power of 1. But this one right here, the square root of x squared is x, so I've got negative 4x times the square root of 2 minus 4 square roots of 10xy. Okay? Oh, sorry. Okay? And then I made up a doozy. So this one right here. What I suggest you do in this case is you have two options. You can simplify, 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 and then multiply, or multiply and then simplify. I'm going to go ahead and multiply and then simplify. So when I multiply this times this, the cubed root of all this times the cubed root of all this is the cubed root of this times this. So I'm just going to write cubed root of 54 times 24. And I'm not going to multiply those together because it's easier if I leave them alone. A to the 8th times a squared is a to the 10th. I shouldn't mark those out, but b to the 22nd, there's no b. And then c squared. Plus 3 times this times that. So I've got 3 times the cubed root of 54 times 27. A to the 8th, no a, so a to the 8th. B to the 1st, b to the 22nd, so b to the 23rd. C to the 2nd, c to the 7th, so c to the 9th. Okay? So, now I start simplifying. 54 is not anything cubed, but 3 cubed is 27, and 27 times 2 is 54. So I'm going to write that as 27 times 2. 24 is 8 times 3, and 8 is a perfect cube, 3 is not. A to the 10th, I'm going to say a to the largest multiple of 3 is 9 times just a to the first, what's left over. Largest multiple of 3 is 21 with 1 left over. And then there isn't a 3 that goes into that, so I leave it like that. Okay, so cubed root of 27 is 3. Cubed root of 2 doesn't exist. Okay. Well, it's not a whole number anyway. Cubed root of 8 is 2. Cubed root of 3, it's not a whole number, so I'll leave it inside. Cubed root of 8 to the 9th, well, 9 divided by 3 is 3. and then a to the first left in. b to the 27th, or 21st, 21 divided by 3 is 7. b to the first left hand side, c squared left hand side. So the only other thing I would say is 3 times 2 is 6, a cubed, b to the 7th, times the cubed root of 6, a, b, c squared. So now let's do this one. Again, 54 is 27 times 2. 27 is just, no, it's just 27, because the cubed root of 27 is a whole number. I'm going to go ahead and say a to the largest multiple of 3 is 6 with 2 left over. Largest multiple of 3 is 21 with 2 left over. And c to the 9th is a multiple of 3. So I've got 3 times the cubed root of all this. So I've got 3. The cubed root of 27 is 3. Cubed root of 2, not a whole number, so I'll leave it inside. Cubed root of 27 is 3. Cubed root of a to the 6, 6 divided by 3 is 2, so a squared, leave a squared inside. b to the 7th, leave b squared inside, and then c to the 3rd. So then I say 3 times 3 times 3 is 27, a squared, b to the 7th, c to the 3rd, times the cubed root of 2a squared, b squared. Okay, so there's that. And then this is the problem that I assigned for the homework. So I'll just leave it up there for a minute and let you write it down if you need to, and that's that.